Hi, my name is Amelia Beltrame, and this is the group I19 project number 2. I'll begin with the video. The first graph displayed is the position versus time graph of the ruler in motion using the Vernier app. Based off the graph, the radius of the motion was relatively uniform throughout its motion, and the angle theta repeats roughly at about 0.2 seconds every rotation. This second graph, also from the Vernier app, displays the velocity and time graph of the ruler in motion. And based off the graph, it is clear to see that the angular velocity and the radial velocity stay almost consistent throughout the whole motion. On the next two slides, in comparison, it shows the position and time graph and the velocity and time graph of the ruler in motion using Excel. Both graphs, looking almost identical to the previous ones, showed that used the Vernier app. In this next slide, however, we were able to graph the acceleration of the ruler in motion with Excel, and just by looking at it, it is clear that there is some inconsistency. In this slide and the next, it displays all the numerical data obtained by the Vernier app while the ruler was in motion. And by using the data obtained, we were able to input the numbers into Excel and graph the results that were previously shown. Next is variable analysis. The change is rotational position when the physical location of the ruler is stationary. The angular velocity is most likely displayed at each point in the velocity versus time graph. The acceleration is a trend towards zero radial acceleration. The only reason that it is not consistently zero is due to human error and the friction of the spinning. This is a quick comparison between the Vernier and Excel graphs. In the Vernier graphs, the X and Y components are separate. In the Excel, they're together. In the Vernier app, it's more precise compared to Excel as it uses data plotted directly from the video, but Excel can only graph when given points from the Vernier app. Both the Vernier and Excel do not graph the line of best fit. The Vernier graphs data points taken from the video of the moving object, while Excel graphs using data points only, and the Vernier app plots graphs gaps if there are any, but the Excel will not. For our question, we said that given the mass of the ruler is 45 grams, find the rotational kinetic energy at 0.6 seconds when the radius is 0.76 meters and the angular velocity is negative 3.99 rads per second. We use the kinetic energy formula, which is 1/2 mass times velocity squared. Using the values given in the question to solve the question, we finished with negative 0.136 joules as the amount of rotational kinetic energy possessed by the ruler. By completing this assignment, we learned that the slope and area mean in both linear and circular motion and how they differ from distance versus time to velocity versus time to acceleration versus time graphs, and how the graphs of rotational motion look in terms of X and Y components when it comes to rotational motion of an object in a single spot moving at a relatively constant speed. Thank you for watching.